Tensile testing in UTM is a method for measuring the strength and ductility of materials by applying a tensile force. It involves stretching a sample of material until it breaks and measuring the amount of force applied and the amount of displacement of the sample. It can provide information about the material's strength, elongation, yield strength, and elasticity. It is commonly used to evaluate the strength and ductility of a variety of materials, including metals, plastics, and composites. With this introduction, we'll get into the experiment. In order to start the test, first we will fix our specimen on the UTM, and after that we'll set up the software. So the software used here is Engr.JOY Blue Hill 2. So we'll see how to set the software. First we'll go to the method, and in methods you can see there are a number of tests available. So if you have already performed any test, it would be saved over there. So in that case we can recall it, or else we can specify the test as a new test. So now I will specify a new test. If it is new test, then we have to specify each and every parameters which are on the extreme left side. So first we will go to the control. Here we will specify the rate of crosshead movement. According to my requirement, I need it to be 1.5 millimeter per minute. So I'll set up it. And then we'll go to the raw data section. In the raw data section, we can see there are a number of parameters available on the left hand side. So whichever the parameters we want, we can click and drag from the left box to the right box. So it's already available extension and load. Now I need some more parameters, so I'll drag it from the left side. Tensile stress and tensile strain I need, so I'll bring them also into the right hand box. And then we will go to the specimen box. So there we need to set up all the parameters of the specimen, the length, width, thickness. So this data we will fix in the specimen box. Then I will check the graph. So there are two graphs, graph 1 and graph 2. So one is for tensile stress versus tensile strain, and the other one is for load versus extension. So these two graphs usually we obtain from a tensile experiment. So we'll usually have these two graphs. After we set up all the parameters, we can save this test. And once we save all these parameters, then we will specify a location where these data need to be saved. So I'll click test, and then I'll browse, because I have already done some tests, so I want to save my file in the same folder. So I'll go to browse, and I'll put another folder to this new test. So I'll click browse, and I'll go to the drop down menu to see my file. So now I found my folder, and there I'll set up another folder for this particular test. I'll give a name for this folder, and within the folder I'll give another name for the test. Once you are done, you can save, and now we are ready to go to the test. Either we can give the testing parameters here, the width, thickness, length, so these details here, or we can go to test, and here also we can give the parameters. Once you input all your parameters, go to balanced load and reset gets in. So this will bring these two parameters to almost 0. Okay, and then start. Once the test is started, the UTM will apply load on the specimen, and which will create extension on the specimen. This extension is shown in the x-axis and the load is shown in the y-axis. With the increase of force at a stage, the crack would start on the specimen, which is called as crack initiation. Either it can be a metallic sample or composite sample. The crack initiation will start, and along with time this crack will propagate, which is called as crack propagation. As you can see here, the crack initiated on the edge is now propagated, and which will eventually last in the fracture of the specimen. The fracture can either be a brittle fracture or ductile fracture. So the specimen which is shown here is a composite, so this is undergoing a ductile fracture. Usually the metallic specimens which undergo ductile fracture, they will show a cup and cone structure on the fracture face. But here in this composite specimen, this cup and cone shape is not observed, but a different shape is observed. Also, when you see the tensile stress versus tensile strain graph or load versus extension graph, the graph is kind of different from what you see from the usual textbooks. And in case if I want to delete any tests, say for example, so these tests they are here, so these data I want to delete them. So what I can do is I will go here, right, whichever the respective test is, right click and delete specimen. So if I delete, the particular value here will be deleted, and these values will also change. Why? Because this range, medium, maximum, minimum, though this is the data of these 7 tests. So if I delete any one of these, this data will change. Say for example, so I want to delete number 7, right click, delete specimen. This will permanently delete. OK, so now it's deleted. And similarly I am going to delete these also. So 6, delete specimen, 5, delete specimen, and 4. So now you see here the range and the data is completely changed. Once your experiment is done, okay, go to finish sample. So this will finish our test. If you want to continue, then we can continue testing. I am done, so I am going to finish testing. Do you want to start another new sample using same test? I don't want. No. Do you want to save the changes before closing it? Yes. And I will give a name. Okay. So if we give a name here and save it, this tensile particular test will be saved in the software. So when I test the next time, if I want to test with the same parameters, okay, it will show me. So I put save, so I don't have to search next time. It's here, 10 CPP. So this is the name I gave. So if I open this one, it will show the already available test parameters which I put today. Say for example, RAM test speed, this is 1.5 mm per second, date, and which are the results I am expecting. So I can reduce or increase these results. So according to the test, it depends. See, so for this person need only these 3: modulus, composite load, and composite loaded tensile strength. But I need this also, right? Maximum load, maximum strength. So dependent. So whichever the test we are selecting here, those parameters will appear here. So when I test next time, I will have those parameters. But again, if I want to have some more parameters, I can add them while testing again. Now I will open my file. This is my file. This is the test today I have done. I will open. Right, so these are the tests we have done today. You see here, these values which we obtained already are available as the PDF format. Similarly, we can have them in the Excel also, right? So this is the final values which we obtain in the Excel, as similar to that of the PDF. Also, we can have the individual results. So raw data. So these are the raw data of all 3 specimens. So here we have the time, extension, load, tensile stress, and tensile strain. So with these values we can plot a graph if we want to, right? So here we have 3 raw samples. In the PDF we have 3 results. Okay, then as usual I'll send this file to my pen drive so that I can draw graph if I want in Excel. That's it. So Tensile C100, it's here. You see here. Alright, so this is how we do this practical.